Welcome to Homework Lib.
This is chapter 35, problem number 46. We have a satellite. The intensity of the transmitted wave is measured at points along the circle, which we have a satellite at the center. In part A, we're asked to calculate at how many other angles in the range from 0 to 90 degrees is the intensity also same, 2 watts per meter squared. So we're looking for, within this range, we're looking for the number of maximas then, right? So the idea is the number of maxima is going to be equal to d over lambda, assuming that sine 90 from the formula. So lambda is going to be equal to the speed of light divided by the frequency. Because we're given frequency, we might as well write everything in terms of what's given to us, right? So d times frequency over speed of light is going to give us the number of maxima. 5.18 meters is the distance. Frequency is 1575.42 times 10 to the power 6 hertz divided by 3 times 10 to the power 8 meters per second. We find it to be 27.2. Of course, we're going to roll down to the nearest integer. Thus, it's going to be 27. There's going to be 27 angles, right? Now, in part B, we're asked to calculate the 4 smallest angles. Again, the sine theta is going to be n lambda, right? So sine theta is n lambda divided by d, then if you divide both sides here by d. So the then angle is going to be inverse of sine n lambda over d. Let's write everything in terms of the frequency. So it's going to be mc over df. Now, at this point, all we need to do is to put different values of m here, starting with the minimum, m equals 1. Then what happens to the angle? The angle would be equal to the inverse of the sine, 1 times 3 times 10 to the power 8 meters per second, divided by 5.18 meters times 1575.42 times 10 to the power 6. So if we do this, we find the minimum angle, let's call this theta 1, to be 2.1 degrees. Next step is to look what angle corresponds to m equals 2, right? Pretty much the same algebra, only this number is going to change to 2 now. So if we do that, 4.2 degrees is what we're going to find. Let's go to the next page. So m equals 3, theta 3. You're going to find that out to be 6.33 degrees. For m equals 4, we're going to have theta 4 equals 8.46 degrees. So we found the four smallest angles. In part C, we're given the angle, we're asked to calculate the intensity at that angle. So it's I naught cosine square pi d sine theta over lambda, as you remember. Again, lambda is c over f. So let's write the intensity in terms of that. Cosine square pi d sine theta, frequency divided by the speed of light then. So I naught here is 2 watts per meter squared. We know pi d, and angle is also given to us as 4.65 degrees. So by plugging everything in this equation, cosine square 3.14, 5.18 meters, sine of 4.65 degrees, and frequency was 1575.42 times 10 to the power 6, divided by 3 times 10 to the power 8. Let's just remember inside here, it should be in terms of radians, not degrees. So if we do that, we're going to find the answer to be 1.28 watts per meter squared.